Okay, in section 4 of hydrostatic chapter, we just need to identify the location of the resultant force. So far, we understand how we can calculate the force. Now we need to just identify the location for a force on a vertical surface. Imagine we had this dam reservoir, and this is the surface, and the pressure of the water acting vertically or in right angles towards the surface here, and we this kind of like a distribution, and we can have the depth h, and at the bottom the pressure is rho gh, and we can see here the distribution is increasing linearly like this one in here. One thing is very important for like a simple triangle pressure intensity diagram. The location of the resultant force acts as the 1/3 from the base. So at the point that we just denoted by P in here, the point P is called the center of the pressure. The center of pressure is the pressure of the resultant force. Once we calculate the resultant force, the location of that acts as point P in here, which is a 1/3 from the base. So the most important things to know is that in most complex problem, we don't know the simple rule where the location of P is. And for that reason, we're just gonna use like a general term of HP. HP is the vertical depth of the center of the pressure, which is the depth of that kind of like the pressure to the water surface. We can calculate that one by using a general form and the general formula of this one. HP is equal to open bracket IG, which is the second moment of the area, divided by A, the surface area of the body, which is in here, H times the width at the bottom of the ratio, HG, which we learn from the previous session, that is the center of the vertical depth of the centroid, which is the center of this rectangular the depth, point G, and close bracket plus HG. So HG is repeated once again. So HP is calculated by using this formula. It's a very simple formula, but it's very practical that we just need to memorize that one. So the question here is that what is the second moment of area? So if you have remember from other previous modules from the structural mechanics and other the modules that you had in the past, we can just use some sort of the lookup table to just calculate the geometrical properties of some simple figures. So which you can see in here. For example, for rectangular, with the width L, height D, the location of the centroid is a D second, and the second moment of the area, for example, for vertically, it can be calculated L times D cubed over 12. Or in a figure like this one, you can see, if you just assuming that X is in the horizontal axis at the bottom and the Y is the vertical axis at the left-hand side of the rectangle shape. So the IXX, the second moment of area, can be calculated BH cubed over 3, and the BIYY, the second moment area in Y-axis, can be calculated B cubed H over 3. Just bear in mind the axis, the origin of the axis is at the corner of the rectangular. This is not the case in many the rectangular or many other shapes. Axis in some cases or many cases can be located at the centroid, for example, like this one. And if the origin is exactly at the centroid, the IXX can be calculated with this dimension, BH cubed over 12, and accordingly, IYY, which is the Y is in the vertical axis, can be calculated once the origin is at the centroid, is H B cubed over 12. So just bear in mind. So that is the understanding of the location. So we're just gonna, in the next presentation, we're just gonna go through with the one example relevant to calculating of the force and the location of the force, hydrostatic force.